Okay, so yeah, like I said, welcome back. I'm recording now. This would be week, I think, 13, lecture number 2. We only have about 2 weeks left, or meaning we will finish this whole course next week, leaving us some time for review. So let's get started with this concept of double replacement. Now, just a reminder, in single replacement, you need the activity series to see if one chemical is more reactive than another. For a double replacement, you don't actually need that. These chemicals are in solution together. They're going to bump into each other. What we really need to see is, will there be a chemical reaction happening? Okay, oops, didn't mean to put the question mark there. So a hint I wrote for you guys yesterday is, if you want to see, or if you want to know if a double replacement happens, the products must include a solid, liquid, or gas. And specifically today, we're going to look at precipitation formation. How can we tell, without stepping foot in a laboratory, how can we tell if we would get a solid? Neutralization, like I mentioned, is something we would deal with in Chemistry 1121. That's your second chemistry course. Gas formation we looked at the other day. So precipitate, how do we know? How can we do this without going into the lab? Well, just remember what a precipitate is. Oh yeah, sorry. And Iman mentioned something about the periodic table for nonmetals. Yeah, that's for single replacement. Yes. Okay. Good point. Basically, our data booklet, it gives us enough information. So speaking of the data booklet and speaking of that question, you know, when you do your final, you're not going to be in the lab, right? You're not going to have chemicals to mix together. So how do we know if a reaction, specifically a double replacement, would happen without an experiment? Well, your data book has all information needed. A precipitate is when a new solid is formed. The key for a double replacement reaction, guys, I'm going to put a big star here, is if all of your products in a double replacement are aqueous, nothing has happened. When things are aqueous, and I'll look a little deeper into this in the next section, but when things are all aqueous, they're not actually it's not a chemical reaction. Aqueous just means that the ions are in the solution. So we need to look to see if we have, for example, a solid. How do you do that? Well, you look at your solubility table. Now, I will quickly review, once we do the practice problems, I will quickly review the solubility table, but I think this is like my last time looking with you at the solubility table. We've looked at it like 10 times back in chapter 4, in chapter 5. Hopefully most of you know how to use that table, but I will show you one more time today when we do the practice problem. So guys, this information here that I'm circling in the cloud, I got this from my solubility table. So we will practice this in a few minutes. So I have two examples on the bottom. I have sodium chloride aqueous and lead 2 nitrate aqueous. So they're both liquids in the lab, meaning the phase is liquid, but specifically they are aqueous, meaning these are dissolved in water. But when I mix them together, I get a precipitate. So the way that you tell if you have a precipitate is to use your table. Just a little reminder, the way a double replacement works is you take each element and switch their partners. What I mean is, in this case, the sodium and the lead would switch. In this case here, the sodium and the potassium would switch. In the bottom example, no product that I get is a solid. They are all aqueous, which means I would write no reaction. The minute you get a solid, this is a chemical reaction, which means you have to balance it, include all of your phases. Okay, now again, if anybody's confused, there are practice problems coming up. So there's a question in the chat from Aman. For no reaction, you find the yes, yeah, and we're going to practice this in a minute. So what Aman said was, for no reaction, you actually find the product, and once there is no solid, you erase and write NR. That is exactly what you do. I couldn't have said it any better. So when we practice these in a minute, you're going to notice that I am going to write the reaction. I'm going to pretend that the reaction happens. But once I write the product and notice that there is no solid, I will cross that out or erase it. I know most of you use pens, which is my nightmare. Drives me crazy, but everybody here uses pens. If you were using a pen, you would cross that out and just write no reaction. And I'm going to show, well, we'll do this in a minute. The other one that we'll look at, and this is not on your final, so you don't need to study this slide, but this is something you'll do in chemistry 2. Anybody going to chemistry 2. So my chemical engineers, some of my medical science students, you would look at this in greater detail in chemistry 2. When you mix an acid and a base, this is a challenging one to think about because you're not, like, imagine you're doing this in the lab. You're not going to get a solid. Sometimes you're also not going to get a gas. You would get a liquid. How on earth would you know this is a reaction if it's just a liquid? Well, in the lab number 10 that you did this week, you noticed that it felt really warm or hot. This is something you'll look at in greater detail in chemistry 2. So I'll kind of leave this for now, and we'll look at some practice problems. But Abdul Halim obviously knows what he's talking about or has done chemistry before. You are correct. Acid plus base typically results in a salt. Sodium chloride is a good example, and water. Aman mentions that we should balance this equation, which you could balance this if you want to for the complete reaction, but we're not, again, we're not really going to worry about this. This is already balanced, 1, 1, 1, already perfectly balanced. I have is it balanced? Yeah, it is balanced. So I have enough information here to balance this. I have 2 hydrogens, I have 1 chlorine, 1 sodium, 1 oxygen. Everything's already balanced. But Aman does mention a good point. Anytime you write a chemical reaction, you're going to balance it. Okay. So I have 2 practice problems here. If you guys printed your notes, you might notice these are a little different. I've kind of worded them or rearranged them to be a little bit more like what you would see on your final exam. These are 2 double replacement reactions. Now they look very similar, don't they? We have silver nitrate and sodium chloride. We have potassium nitrate and silver chloride, very almost identical chemical reactions. The only difference here is one of them has silver and one of them has potassium. Before I do these answers, I would like to see if any of you can do this. What you need to do, I'll give you a hint to get you started. What you need to do is first you need to write your products. Don't worry about balancing at first, but what I would recommend what I recommend doing for a double replacement is to swap means switch your metal ions. So what I would do to get started is I can't count how many times I've done that, not switch to my pen. Switch the silver and the sodium. Again, imagine these guys are lab partners. So you have silver and nitrate together, you have sodium and chlorine together, and you're going to trade partners. So the silver goes with the chlorine, the sodium goes with the nitrate, NO3. So what I would like for you guys to do is write the products, and then you're going to need your solubility table. Now, I'm aware that a lot of you do not have your solubility table with you. So if you don't, at least write the products of this reaction, make sure it's balanced, and then together as a team, we will look at your solubility table to see if we get a precipitate. So I'll give you guys maybe 2 or 3 minutes to try this. And then I'll check your answers, okay? So I have an answer there from one student there. I'll pause or I'll mute myself and give you guys a couple minutes to try this. Just a hint, one of these is probably a reaction and the other is probably no reaction, but I don't know which. So I'll give you guys a few minutes. I'll be back maybe in 2 or 3 minutes. Again, if you don't know what to do, just kind of try your best and we'll look at the answers soon. So I'll be right back. Good luck. Try these. Okay, so let's have a little look here at your answers. Sorry, I just had to clear up some writing there. Okay, so yeah, so and again, I'm a little, there's some interesting answers here, a little different than my first class. Abdul Halim asked the question for the first one, the solubility table. I can see that silver is not soluble with chlorine. Do I need to do the equation? The answer is absolutely, because that's what you're looking for. When something isn't soluble, you get a precipitate. A precipitate means the chemical reaction happened. If your products are all aqueous, there is no reaction. So let's look at our answers here. So first things first, I will write my chemical formulas. So I'm going to have AgCl. Okay, the silver goes with the chlorine, and I'll have NaNO3. In the second one, I will have KNO3 plus KCl, my bad. KCl and NaNO3. Now, guys, these are already balanced, so I don't need to do anything there. But what I really need to do is look at the phases, the states of matter. And what I more specifically need to do is go to my data booklet and look at the solubility table for this. Okay, so data booklet, here we go. Let me open this up for you. I'll share my screen. All right, so we have NaC. Okay, so we have compounds that are bonded to chlorine, and we have compounds that are bonded to nitrate, NO3. Let's do the nitrate because it's one of my favorite ions. I love nitrate because it's so easy to work with. Nitrates, all nitrates are soluble. Every nitrate compound, sodium, potassium, iron, lead, zinc, everything with a nitrate is soluble. Chlorine, however, has a little bit more work to do. So with chlorine, most chlorides are soluble, okay? Except insoluble, we have chromium, copper, gold, but more specifically, we have silver. Silver chloride, AgCl, is a solid. NaCl is, of course, aqueous. You guys know that. I hope table salt definitely dissolves in water. But silver chloride is relatively insoluble. So going back to my notes, I'm going to write this information. Everything with a nitrate is aqueous. For my chlorine, I need to kind of separate them. So aqueous here, for my nitrate, aqueous here, no problem. The silver is solid, the potassium is aqueous. Okay, so guys, in the first equation, I am getting a precipitate. In the second equation, they are all aqueous. And because they're all aqueous, I would write NR, no reaction. So now, as Aman said earlier, typically I would just erase my information and write NR, but I know you guys prefer to use pens. Again, my nightmare is people using pens in chemistry, but that's fine. And if you used a pen, you would just cross out this, no reaction. If your products are aqueous, it's no reaction. Nothing happened. In order for a reaction to happen, your product needs to be a solid, liquid, or gas. All right. As Aman asked the question, will this be multiple choice? No. So this is not, you on the exam will have to do this question just like I did it on this slide. You will have to write the products. Okay. It sounds hard, but it's not. If you guys practice a little bit with your worksheets, it's pretty straightforward. But this type of question, and I have seen your final exam. We finished it maybe on Thursday, I think we finished it. I've seen the final. This you would definitely have to write just like I did on this. Oops, sorry. Like I did on this PowerPoint. You would have to write the products. All right, so that's it. That's reactions done. Halas, finished. There's only one little thing I want to do today, and it should take me maybe 10 minutes or so, and we're done. And then I can go to the lab and you guys can take a break. Although I think I have some of you today in my lab as well. All right, now before I move into the next section, any questions on this? If there's no questions, or sorry, and even if there are questions, don't forget, you can always ask me, send me an email. We can always have a one-on-one meeting or something. All right, so let's go through, or let's move on, I should say. Now, oh, am I recording again? I am. Okay, good. All right. So the next story, I just had an email from a student about the lab today. All right. Anyways, Ganem, well, easy answer to the weight of your final. The final is 50%. So it's huge. It's worth a lot of marks. Okay. So again, guys, I will definitely give you some hints and review and talk about your final next week when we're closer to it. My plan is to have at least 2 classes where we'll talk about the final. Oh, there goes my dog. Iman, if you have a reaction, so on like your test, you looked at a reaction, you always mention phase. Always. If you didn't write the phase, you might lose a part mark or something. Always include solid, liquid, gas, or aqueous. You can think of a chemical equation like a sentence in communications. You know, you need a subject. I don't know much about communications, but you know, a full sentence has like a topic or a subject. It has correct grammar, you know, a capital letter at the beginning, a period at the end. Chemistry is the same way. A complete chemical equation has a structure. It has reactants and products with an arrow. It has a balanced chemical equation, and we always include phases: solid, liquid, gas, or aqueous. Which brings me to the last part. Today I'm going to review basically what you did in the lab. If you've done the lab, if you haven't done the lab, this will be the first time, but it's pretty straightforward. So first, a little reminder, what does aqueous mean? Aqueous means dissolved in water. When something's dissolved in water, or when something's aqueous, what's happening is the ions are breaking apart to form, or I guess I should say the solid is breaking apart to form ions. So like imagine you're putting table salt into water. You take white crystals, white solid table salt, sodium chloride, you put it in water, and somehow they magically disappear. What's going on? How do these chemicals disappear? Well, what's happening is the water molecules are surrounding the ions because it's soluble. They hydrate these ions and they split them into their ionic form. So a solid substance like NaCl can turn into an aqueous solution where it dissolves, it mixes, it disappears. So we're going to look at this in specifically talking about net ionic equations. Now, before I get into that, I'm just about the question in the chat there. Aman, if the question just said balance the equation, you don't need to include phases because it's just asking you to balance it. Okay, but don't worry about your test until I get your marks completed. So you can ask me more questions about that tomorrow. Okay, so first things first. What happens when we put something in water? Well, it dissociates. Now, this is not a test or a final exam question. This is getting us ready for the next question, which is definitely something you need to know. So if I took this solution, I mixed it in water, what would happen is it would split into its ions. We always have a cation and an anion. This is basically review of chapter 3. Right? If you had to name this chemical, you would name the cation, you would name the anion. Well, a dissociation equation means to split something into its relevant ions. So potassium phosphate, this chemical here on the left, it would be split into 3 potassium ions and 1 phosphate ion. You'll notice that the charges are equal. This is again from unit 3. Barium hydroxide, when you put that in water, you would get barium 2 plus and hydroxide OH minus. Remember, these chemicals are polyatomic. So you would get those from your data booklet. Now, this isn't really a question. This is not a slide you need to study. This is getting us ready for the next part and kind of the finale of today's class. On your final exam, you will have one question where you will have to write, just like you did in Lab 10, the net ionic and the total ionic equation. So in many chemical reactions, we're mixing together aqueous solutions. There's a few reasons for that. One, they're cheap, they're easy to find. Two, they react very well because for a chemical reaction to happen, they need to be the chemicals need to bump into each other, and that happens nice in a liquid. And 3, liquids are easy to work with. It's very hard to work with gases. It's very hard to get solids to mix, but liquids, you can stir them together very easily. So in many chemical reactions, we are dealing with aqueous chemicals, meaning we've taken something and we've dissolved it in water. So anytime in the lab you have like a bottle, with that little like stopper on it, the little squeeze bottle, that's an aqueous solution. Sorry, I'm not a very good artist, but those little squeeze bottles you see in the lab, the little pipettes, that's an aqueous solution. So one thing or one, I guess, subject to look at is when you have a chemical reaction, which ions are actually involved in that equation. And to do that, we would write a net ionic equation. To do a net ionic equation, the first thing you do is write out the total ionic equation, meaning I'm going to take anything that's aqueous, any chemical here that's aqueous, I'm going to write these down as their ionic forms. Remember, aqueous means that they have been dissolved or dissociated in water. For this compound, the lead, I cannot split. I cannot dissociate this. This is a solid. It does not dissociate. It's a precipitate. Remember, dissociate just means separate. So what I would do, and I'm going to show you one of these together. So if this doesn't make sense, I'm going to show you one for practice. But what I would do is I would split the sodium chloride into sodium ions and chlorine ions. I would split the lead and the nitrate into its ions. And I would split the sodium and then other nitrate into its ions. Remember, the solid, the precipitate, you leave. Do not mess with it. Aman, same thing for gases and liquids. If it's a gas or liquid, same thing. Gases or liquids or solids, they are not dissociating in water. Aqueous literally means that this chemical has split in water, separated. So, what is the point of a total ionic equation? Why am I showing you this? Well, using your total ionic equation, you can break this down into a net ionic equation. The net ionic is the equation that shows exactly what ions are reacting. We're getting rid of any chemicals that do not react. To do this, you need to think of a new term or a new word. The word is spectator ions. Spectator ions are ions that do not involve or are not involved in the overall reaction. So guys, think about what the word spectator means. Think about back when life was normal and maybe you went to watch a football match, a tennis match, maybe you went to Novo or Vox Cinemas to watch a movie. When you're watching a sporting event or you're watching a film, you are not involved. You have no outcome on the soccer match. Football match. You have no outcome on the film. You are what's called a spectator. Spectators are not important for overall chemical reactions. They're just there. They're hanging around, they're watching it happen, but they are not involved. To figure out in a net ionic equation which chemicals are spectators, you cancel any chemicals that are the exact same on both sides. So spectator ions are the same on both sides. Now, what do I mean by sides? I mean on the left of the arrow and on the right of the arrow. So sodium, now I'm sorry for this, the PowerPoint doesn't really let me write a long equation. This is my arrow in the middle. Sodium is the same, nitrate is the same, and that leaves me with my net ionic. The chemical reaction happening here is that the chlorine ions are mixing with the lead ions to create a precipitate. Now, I got 2 more slides and we're finished. The next example truly explains why, if you have all aqueous, is it no reaction, right? Like think about that. 10, 15 minutes ago, I told you for a double replacement reaction, if everything is aqueous, why wouldn't that be a chemical reaction? Well, look at this situation, this chemical reaction. Again, I apologize, the arrow is in the middle because of how PowerPoint works. Every chemical here cancels. If all of the chemicals cancel, then I don't have a reaction. Nothing happened, right? I didn't form a solid, I didn't form a liquid, I didn't form a gas. None of these chemicals are forming a new compound. So guys, the finale of today, I'm going to do one for you. You did see this in the lab, so some of you have experience with this, but I'm going to do one for you. And then tomorrow, I want you guys to come to class and have this one, try this one. So slide 54, I would like for you guys to try this tomorrow. But for today, let me finish by showing you an example. Okay, so here we go. Any chemical that's aqueous, any aqueous chemical, separate it into its ions. Any solid, liquid, or gas, and specifically solid, because that's what you're really going to see, leave it. Don't touch solids, liquids, or gases. They are new chemicals. Okay, now I will apologize. I'm going to have to write really small here. Well, not really small, but you'll see. So I'm going to split, oops, sorry, I want to pick red. I'm going to split magnesium chloride, sodium hydroxide, and sodium chloride into its ions. So magnesium Mg2 plus, that's of course aqueous, and I get 2 chlorine ions. This is review from chapter 5. Or sorry, chapter 3. I'm just, imagine doing a reverse name. I'm taking the magnesium and chlorine and writing what ions I have. Okay, here I get 2 sodium ions and 2 hydroxide ions. Okay, so I just split everything into its ions, nothing serious. I'm just, writing them out. I'm making sure I include my numbers. If I have 2 of them, I put them in there. Now, MgOH2, do not touch. That's our new chemical. And then I have 2 sodiums and 2 chlorines. Sorry, writing small there. Again, I don't have a whole lot of room. My screen is quite small. Aman asks a very good question. When you do this question on, say, a final exam, will it be balanced? The answer is yes. We will balance these equations for you if you had to do this. Okay? All right. Now, the hard part is done. This is the fun part. I always love this part of chemistry part of net ionic equations, because all I need to do now is cancel any chemical that appears on the left and any chemical that appears on the right. And I'm done. Halas. So, sodium, see you later. Chlorine, see you later. And what I have left is magnesium hydroxide, and then my chemical, magnesium hydroxide. So my net ionic equation here would be, oops, I do that all the time. I forget to change to my pen. It would be magnesium 2 plus aqueous plus 2 hydroxide molecules, aqueous of course, and my chemical, my precipitate. It's already balanced. I don't need to mess with balancing. I just need to show the net ionic. So there it is. This compound is the chemical that I form. This equation are the chemicals that form my compound. So guys, that's it for me. We will do this problem tomorrow. I'm out of time because I do have to go to my lab, but that's it for today. If anybody is still confused, we will practice this tomorrow, but other than that, I'm done. So if there's any questions, let me know in the chat. Other than that, you are free to go.